So now in this video, I thought we would just make a quick circuit. The integrated circuit that we had on the board, I got from this kit. So it says on there CD4023BE on the integrated circuit, but it's just CD4023 on here. It's probably an improved version. So it's a triple 3-input NAND gate. So not AND, but NAND. That's important to realize. You have to power it. Positive supply goes there. Negative supply goes there. Now, there's 3 NAND gates, and here are the outputs. Basically, down at the bottom, there's an input down there as well. But in any case, we're just using number 1 there. It makes things simple. It's right above ground, and then the 3 pins above it are its inputs. To use the number 3 one right there, right below the positive supply is the 3 inputs, and the output is right below that. 2 is more complicated. So 2, second one up, we have the output there, and we would have to use 1 of the inputs is right below it there, and then the other 2 are up there. You can see 2, but we're just using 1, so left side there, those 4 pins. So now we are back to the breadboard there. I got 5 volts. Apparently we can go from 3 volts to 18 volts with this integrated circuit right there. Although the output does not look like it can provide a ton of current right there. We should be getting a higher amount of current. I'm going to zoom in so you can see what I'm going to do here. So we have the long lead, the anode to the output right there. As you can see, it's got to be more positive to light up than the cathode, the shorter lead. And so what I'm going to do is I'm going to spin this, and I put the shorter lead, the cathode, to ground, longer lead, the anode, down 1 spot, and I'm looking through the camera when I do that, so aim could be iffy. So again, this resistor is to ground, and yeah, that's what I gotta do. I gotta put it to the positive supply right there. And there you can see the LED lights up, and when we come back, it's 13 milliamps of current, and that's how much it should be if the output was providing the full 5 volts at 20 milliamps of current. So it looks low, and so what we're going to do is put the LED back. So we have a limitation, it looks like, on what the current can be provided from the output, and that really got bent out of shape. There we go. We're going to put long lead to the output again, short lead the cathode, down 1 spot, and so again, that would be the current we would get if we could get all the way to the positive supply. Now we'll plug that in. So I probably should just use the 1K resistor like I did with the blue one right there, 1000 ohms, but we got 220. So in any case, we'll zoom we'll zoom back in. Now, since this is a NAND gate, all the inputs have to be high for the output to be low. It's the opposite of an AND gate. It's not an AND gate. It's a way to think of it. And is not AND. So, output's high, and a red LED lit up going to ground. So it's going to do that. I can put that one to high, and then the red one to high right there. Now, when I yank this one, half the time it's high, half the time it's low. It's picking up stray signals in the air. It's really sensitive signals. I don't even have to touch it. There you can see it's already flashing back and forth really quickly. But there we go. All 3 are high now, and the output is low. That's the only time the output will be low. And we can, shuffle backwards the other way. Again, that was picking up stray signals. It was alternating between high and low. And that one will go low. So yeah, we've done all the situations now where if 1 or more are low, then the output's going to be high. The output's only low if they're all high, all of the inputs. Again, the opposite of an AND gate. So yeah, this is just a simple circuit, and we'll zoom back, look at how much current we need for the blue LED. But the blue LED has a 1000 ohm resistor, so it's already trying to limit current pretty good. That's actually what we expect, about 2 milliamps of current right there. I'm not sure what the output can be, but the input can be I don't think we want to go up to 18 volts. That's what it says, and it is you know, gonna go be able to provide more current as you raise the voltage. But again, I think we might be limited. So yeah, we can go to 12 with the blue LED. Now let's lower this to let's go back to 5 for when we got the red LED lit up. Again, any input can be low. So we just got one low input right now. The red LED lights up. And let's see what our current limit is. Okay, it goes up pretty quick when we have the so the blue LED is kind of lit up now. That tells me that the output isn't doing what we wanted it to do. It's not high or low, I don't think. Maybe, yeah. That was kind of interesting. So, what I believe was happening was the output wasn't able to provide the power that it needed to. So the current was just going through the resistor, the blue LED, and then the red LED, and the other resistor to ground. So I'm not going to go further on that in this video, maybe the next video. But in any case, again, this was just a kind of a quick video to test out the, I think it's a tri-NAND gate. There's 3 NAND gates in there, 3 input NAND gates as well. 3 NAND gates and 3 inputs. Again, I think you know, you get a lot better in electronics if you just build these simple circuits with whatever components you got. Just take the integrated circuits you got, try to make a simple circuit out of it, and you get a lot more use to it. Again, check the data sheet for the limitations. I think the outputs here are very current limited. They're meant more for giving a signal to other circuitry, where they look at the voltage and don't really need any current. They just respond to it. Again, this test you know, motivated me to learn more about the current and learn why I didn't get the results that I wanted. Ultimately, at a higher voltage, you know, just the red LED being lit up right there. Hopefully that makes sense. Hopefully that wasn't too boring. I know this was a long video. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. And I'm going to make sure I put it back to 5 volts so I don't accidentally fry something if I put a new circuit on here thinking that it's only 5 volts when a higher voltage is applied. See you in the next one.